together. A population of bacteria is growing. The number of bacteria, P, is given by the exponential function below after x hours. So x is measured in hours. How many bacteria did we start with? Well, let's think about what this really means. This really means I'm taking 20 and I'm multiplying it by a 3, a whole bunch of times, x times. So what seems to be a reasonable number that I start with? Oh yeah, 20. And sure enough, that number will always be the starting value. And if you're not sure, what you can always do is substitute in a 0 for your x. Because this is at time x equals 0. So if you substitute in a 0 for x, 3 to the 0 is 1. That's going to give you 20. Okay. B, how is the number of bacteria growing each hour? Well, let's go back to what I wrote before. This is 20 times 3, times 3, times 3, times 3. What do we call that if something is times 3, times 3, times 3? The number of bacteria is tripling. Tripling each hour. It triples each hour. Okay, and about how many bacteria will there be in 4 hours? A lot. But specifically, I can replace my x, because that's my time, with a 4. So you can put that in your calculator or think that's 20 times 3, times 3, times 3, times 3. And that is going to be, let's see, that's 9 times 9, that's 81. 81 times 2 is 162. So it should be 1,620 bacteria. And D, about how many bacteria will there be in 10 hours? Oh my gosh. That's 3 times 3 times 3 times 3 times 3 times 3. I'm not going to do this one in my head. Let's put that in the calculator. That's going to be 20 times 3 with a little caret and the 10. So 20 times 3, the little caret, 10. Woo, that's a big number. 1,1,8,0,9,8,0. I'm not reading have my glasses on, so I hope I did that right. That's 1,180,980 bacteria. So you can see these exponential growth functions, they grow so quickly. They grow so quickly, right? Okay, we just did an exponential growth. Let's do an exponential decay. And I hope you're doing that at home. Exponential growth, let's see it. Exponential decay, let's see it. Nice. All right, so now we have another population of bacteria is dying off. The number of bacteria, P, is given by this exponential function. Okay, so, exponential decay. How many bacteria do we start with? Well, we could put in a 0 for the x, or we could just realize, oh, that's going to be that number always right there, 2,000 bacteria. How is the number of bacteria decaying each hour? Well, we know this is times 1/2, times 1/2, times 1/2, times 1/2, times 1/2. So each hour you have half of what you had before. So it's halving each hour. Each hour. So the number of bacteria is halving. That's a funny thing to say. About how many bacteria will there be in 4 hours? Hey, we can simply replace the x with a 4. And it's always, you can do this in your calculator, but I always like reminding ourselves, it's times 1/2, times 1/2, times 1/2, times 1/2. Let's try this in our head. Half of 2,000 is 1,000. Half of 1,000 is 500. Half of 500 is 250. Half of 250 is 125. But you could do that in your calculator as well. Okay? Let's see if there's another question. About how many bacteria will there be in 10 hours? This one I'm not going to do in my head. I think we're not going to have many bacteria left. So let's see. So 2,000 times 1/2, or 0.5. The caret does our exponent. And, oh yeah, I got about 1.9531. Well, what's that about? How many bacteria? Yeah, maybe about 2 bacteria. Okay? All right. So, that was an example of exponential growth, and the one we just did, exponential decay.
Boys, gonna say down there.